Welcome to Group 27's video presentation of an F180 small size league soccer robot for QT's modified Robo Cup competition. The small size league is for a small robot that plays soccer in an arena with a golf ball. The robot and all of its components must fit within a 180mm diameter cylinder with a max height of 250mm. All computing must be done on board and the robot must run by itself with no communication to an external computer. The robot will navigate an arena whilst avoiding obstacles to search for an orange golf ball. Once the golf ball has been found, a desired goal will be sought out and the robot will kick a goal. All of this will be done with onboard vision using a camera, and a Raspberry Pi will be used to control the robot. This robot is important to learn how we can make self-thinking robots that don't need a human to control. Automation is critical when it comes to robots, as it is more efficient, faster and safer for a robot to do certain tasks.
Group 27's bot is comprised of two layers of acrylic. The bottom layer is 6mm thick to provide a solid and stiff base for the drives to mount to. The upper layer is only 3mm as it is strong enough to hold the components that are situated on it. The wheels are known as omnidirectional wheels. They are made of two discs of 3D printed plastic that form the main wheel hub. Each carries 20 rollers that are free to spin at 90 degrees to the driven axis of rotation. 3 of these wheels are used on the robot. They are spaced at 120 degrees apart and allow the robot to translate in any given direction as well as spin on the spot. The bottom layer houses the kicker and its related electronics as well as the motors, their drivers, the wheel encoders and the Arduino taking care to drive the motors. The Arduino is connected to the Raspberry Pi via serial. Each motor is driven by its own PD loop that keeps the motor at its set velocity until a new velocity is commanded by the artificial intelligence. The top layer houses the Raspberry Pi, the battery and the camera. Further on the top layer is the Dribbler and its drive motor. The Dribbler itself is made of 2 cones transferring spin onto the ball against the robot. This ensures a good hold onto the ball as well as keeping it centered. The whole robot is enclosed in a black plastic shell, making it conformant with the rules as well as protecting the innards.
The vision was done using a Raspberry Pi camera, Python and OpenCV. OpenCV is an open source library of programming functions with a focus on image processing and computer vision. An image could be processed to find positions of objects with relation to the robot. The image was processed by taking an image from the camera, converting the image's color space from sRGB to HSV, and then segmenting the chosen color using known ranges in the HSV color space. Once the colors were segmented, a function called Simple Blob Detector was used to find the location of each object in the image. Lastly, once the location in the image was known, the distance and bearing from the robot was found and was pushed to the AI navigation system.
In the design of AI and navigation systems for mobile soccer playing robots, there are numerous methods that could be undertaken. These methods range from the more complex, such as SEM algorithms, to the simple option of basic reactive navigation. In designing the AI navigation system for the Robot Soccer Challenge, the method of potential fields was chosen. This method of navigation was chosen because it is a relatively simple and easy to tune, but also an effective and elegant algorithm for obstacle avoidance that has been researched thoroughly. In order to arrive at the goal destination, whether it be a ball or a desired goal, the potential field algorithm applies an attractive force toward this object, getting stronger and stronger as you move away. In order to make sure collisions with obstacles and/or other players on the field are avoided, a repulsive field is created around this obstacle or player, getting stronger and stronger as the robot gets closer, thus pushing you away further. Once the attractive and repulsive forces are summed together, the result is a potential field that guides the robot smoothly through the playing field to the ball without collisions.
To conclude, during testing the robot was able to score 1 goal, avoid the obstacle and drive the golf ball into the goal. Separately, the robot was able to hold the ball with the dribbler and shoot at the goal at a good speed. Thank you for watching.